Right now, the sun is doing something you've never once thought about. It is pulling the Earth sideways. Not toward it, not in a straight line, sideways. Earth is moving at roughly 30 kilometers per second through space, and the sun's gravity is constantly bending that motion into a curve. Every single second, the sun tugs Earth about 3 millimeters off the straight line path it would otherwise follow. 3 millimeters per second doesn't sound like much. You shift more than that when you lean forward in your chair. But that tiny, continuous, silent correction is the only reason Earth doesn't fly off into interstellar space like a rock released from a sling. The sun has been making that correction every second for 4.5 billion years without interruption. Not once has it missed. Not once has there been a gap. Until now. The sun vanishes. Not explodes, not goes dark, not gets blocked by something. Vanishes. Every atom of hydrogen, every joule of fusion energy, every photon in transit from its surface, gone. For 10 seconds. Then it comes back, exactly as it was, as if nothing happened. 10 seconds. You can hold your breath longer than that. You can miss 10 seconds of a conversation and not even realize it. You've lost 10 seconds to blinking today and didn't notice. So this should be nothing, right? The sun takes a 10-second coffee break and comes back. What could possibly go wrong? Well, for starters, you wouldn't know. Not for 8 minutes and 20 seconds anyway. And that delay is where this story starts to get uncomfortable. Light travels at roughly 300,000 kilometers per second. The sun is about 150 million kilometers away. So the last photons the sun emitted before vanishing are still racing toward Earth at the speed of light, and they won't arrive for another 8 minutes and 20 seconds. During that time, the sky looks perfectly normal. The sun appears to be right where it always is. Warm, bright, constant. Shadows fall at the same angles. Solar panels generate power. Sunbathers feel warmth on their skin. The world looks and feels exactly the same as it did 5 minutes ago, or 5 years ago, or 5 centuries ago. This is genuinely strange when you think about it. For 8 full minutes after the sun ceases to exist, every human on the day side of Earth is living in a lie. The light hitting your face is a message from a star that isn't there anymore. You are being warmed by a ghost. The entire daytime sky is a delayed broadcast of a show that's already been canceled, and nobody knows. But that's not the worst part, because light isn't the only thing the sun sends our way at the speed of light. Gravity does too. This is one of the most counterintuitive results in all of physics. Before Einstein, people assumed gravity was instantaneous. Newton's equations treated it that way. The sun pulls the Earth pulls the sun, and the force just exists between them, with no delay, no travel time, no speed limit. But general relativity proved that gravity propagates as waves in space-time itself, and those waves travel at exactly the speed of light. Not approximately, exactly. This has been confirmed experimentally. In 2017, the LIGO and Virgo observatories detected gravitational waves from a neutron star merger and measured their speed to match the speed of light to within 1 part in a quadrillion. So when the sun vanishes, the gravitational signal of its disappearance also takes 8 minutes and 20 seconds to reach Earth. For that entire time, Earth doesn't just look like it's orbiting a sun that exists, it is orbiting a sun that exists, as far as the fabric of space-time is concerned. The curvature of space around the sun hasn't flattened out yet at Earth's distance. The dimple in the rubber sheet is still there. Earth keeps curving along its orbit, obedient to a gravitational field that hasn't gotten the memo yet. Then the signal arrives. 8 minutes and 20 seconds after the sun disappeared, the gravitational wavefront reaches Earth at the speed of light. For the next 10 seconds, Earth's local region of spacetime goes flat. Not violently, not with a shock wave, but smoothly. The curvature that was bending Earth's path simply isn't there anymore. And Earth, still moving at 30 kilometers per second, does what any object does when you stop pulling it sideways. It goes straight. Here's where the math starts mattering. Earth's orbital velocity is about 29.8 kilometers per second. In a normal orbit, the sun's gravity curves that path by about 3 millimeters per second. Over 10 seconds, that's a total deflection of roughly 30 millimeters. Not 30 meters, not 30 kilometers, 30 millimeters. About the width of your thumb. That is the total amount by which Earth deviates from its normal orbital position because of 10 seconds of straight-line travel. And you're thinking, 30 millimeters? The Earth is 12,700 kilometers wide. 30 millimeters is nothing. It's less than nothing. You could measure it, technically, with extremely precise instruments, but in practical terms, it's so small, it's meaningless. A cosmic rounding error. But that's not the worst part, because orbits don't forget. An orbit is a perfectly balanced relationship between speed and gravity, and even a microscopic change to either one of those variables doesn't fade away. It compounds. Earth's new trajectory after those 10 seconds of straight-line flight is not the same ellipse it was on before. The orbital parameters have shifted by an almost immeasurably small amount. The semi-major axis, the eccentricity, the argument of perihelion, all of them nudged by fractions of a percent. In the first year, the difference is undetectable. In 10 years, it's still basically noise. But orbital mechanics is a game of compounding interest, and small perturbations grow. The real issue isn't the 30 millimeter offset. The real issue is that Earth is now on a slightly different ellipse, and that ellipse has a slightly different relationship to every other planet in the solar system. Jupiter's gravitational influence, which constantly tugs on Earth's orbit in small but measurable ways, now interacts with a slightly different orbital shape. Over thousands of years, those interactions amplify. The technical term is secular perturbation, and it means that the initial 30 millimeter error grows logarithmically over time as gravitational interactions with other planets magnify it. A computer simulation of the solar system's long-term stability would show Earth's orbit diverging from its original path by meters, then kilometers, then thousands of kilometers over millions of years. And here is the delayed bomb that nobody talks about in the first week. When the sun vanished, it didn't just stop emitting light and gravity, it stopped being a mass. For 10 seconds, the entire solar system lost its central anchor. Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, every asteroid, every comet, every grain of dust orbiting the sun, all of them flew straight for 10 seconds, each one at its own speed, each one in its own direction. The entire architecture of the solar system flinched, and when the sun came back, each planet resumed orbiting from a slightly wrong position, at a slightly wrong angle, with a slightly wrong velocity. Every orbit in the solar system is now a little bit off, and every one of those slightly off orbits is gravitationally tugging on every other slightly off orbit. The solar system is a chaotic system in the mathematical sense. That doesn't mean it's wild or random. It means it's sensitively dependent on initial conditions. Tiny changes to starting conditions produce dramatically different outcomes over long enough timescales. The Lyapunov time for the inner solar system is about 5 million years, meaning that after 5 million years, any uncertainty in planetary positions gets amplified to the point of total unpredictability. 10 seconds of no sun just injected an uncertainty into every orbit simultaneously. The clock is now ticking on a divergence that will, eventually, over geological time, make the solar system's current configuration unrecognizable. But that's millions of years away. Humans don't think in millions of years. Humans think in news cycles. And the news cycle for this event starts 8 minutes and 20 seconds after it happens, when the light finally runs out. If the sun disappeared at noon, the sky would go black at 12:08 and 20 seconds. Not dark like nighttime, black like a cave. The sun provides about 120,000 lux of illumination at Earth's surface on a clear day. That drops to zero in an instant. No gradual dimming, no sunset transition. Full tropical noon to absolute darkness in less than a blink. Streetlights wouldn't kick on fast enough. Automatic headlights on modern cars might react within a second or two. But for a solid 1 to 2 seconds, everyone on the daytime side of Earth is in total unexpected darkness. People driving at highway speed, surgeons mid-operation, construction workers on scaffolding, pilots on visual approach. 2 seconds of total blindness at the worst possible moment for millions of people simultaneously. Then the sun comes back. Because those 10 seconds of disappearance started 8 minutes and 20 seconds ago. And the light from the sun's return takes another 8 minutes and 20 seconds to reach us. So, from Earth's perspective, the blackout lasts exactly 10 seconds. Noon goes dark, stays dark for 10 seconds, then snaps back to full brightness. And we haven't even talked about the thermal effects yet. 10 seconds without solar radiation barely registers on Earth's surface temperature. The planet's thermal mass is so enormous that 10 seconds of no incoming energy changes the global average temperature by a number so small it's essentially zero. The oceans alone absorb and store enough thermal energy to maintain their temperature for weeks without solar input. The atmosphere doesn't cool measurably in 10 seconds. Your coffee wouldn't even lose an extra degree. Thermally, 10 seconds is absolutely nothing. But psychologically, 10 seconds is everything. 8 billion people just watched the sun disappear. Half of them experienced it as a sudden, unexplained blackout that lasted 10 seconds and then resolved. The other half, on the night side, didn't see anything visually, but within minutes they'll see the astronomical data. Observatories detected the gravitational wave of the sun's disappearance and return. Solar telescopes recorded the impossible. Seismometers picked up a faint signal as the gravitational wavefront passed through the Earth itself, causing a barely perceptible compression and relaxation of the planet's mass. And now, everyone knows. The sun can just stop being there. It happened once, for 10 seconds, and it came back. Which means it could happen again. For longer. Maybe forever. There is no physics model, no astrophysics theory, no equation in any textbook that predicts or explains a star temporarily ceasing to exist. Stars are born, they burn, they age, they die. They do not take breaks. The sun vanishing for 10 seconds is not just unprecedented, it is theoretically impossible. It violates conservation of energy on a scale that dwarfs anything humans have ever measured. The mass energy of the sun is roughly 1.989 times 10 to the 30th kilograms. That mass energy went somewhere for 10 seconds and came back. No framework in physics accounts for that. The psychological shock wave is harder to calculate than the orbital deviation, but it's 1,000 times more destructive. Within hours, financial markets collapse. Not because anything physical was permanently damaged, but because every risk model ever written assumed the sun would continue to exist. Every insurance calculation, every mortgage rate, every 30-year treasury bond, every pension fund projection assumed a stable solar system. That assumption just got disproved in 10 seconds. The risk premium on everything changes. If the sun can vanish once, what is the probability it vanishes again? Nobody knows. You cannot assign a probability to an event that is theoretically impossible and has happened exactly once. Actuarial science breaks down completely. Religious institutions offer explanations immediately. Some call it a divine warning. Some call it a test. Some call it the first sign of an approaching end. Conspiracy theories multiply within minutes. Government cover-up, alien technology test, simulation glitch. The theories are all wrong, but they fill a void that science cannot immediately fill, because science has no answer. Not no good answer, no answer at all. A star temporarily stopped existing. The honest scientific response is we have absolutely no idea how that happened, and honesty is not comforting when the thing that happened was your star winking out. And we haven't even talked about what the gravitational wave itself did as it passed through Earth. When the sun vanished, a gravitational wavefront propagated outward at the speed of light. When the sun returned, another wavefront propagated. These aren't the gentle ripples from distant black hole mergers that LIGO detects. These are the gravitational equivalent of someone yanking a bowling ball out of a trampoline and slamming it back. The amplitude depends on the modeling assumptions, but even conservative estimates put the strain at a level detectable by seismometers worldwide. The Earth itself would ring like a bell, a faint but measurable oscillation as the planet's mass adjusted to the sudden flattening and recurving of spacetime. Not an earthquake, more like a planetary shudder. Seismologists would record it on every instrument on Earth, and it would look like nothing in their catalog. A signal with no fault line, no volcanic source, no impact event. A vibration that came from geometry itself. But that's not the worst part. The sun's gravitational influence extends to the edge of the solar system and beyond. The Oort cloud, a hypothetical shell of trillions of icy bodies orbiting at distances of up to 100,000 astronomical units, is held in place by the faintest whisper of solar gravity. At those distances, orbital velocities are measured in meters per second, not kilometers. The gravitational disruption from a 10-second solar absence wouldn't scatter the Oort cloud dramatically, but it would nudge trajectories. Some comets that were in marginally stable orbits would be pushed into slightly different paths. Over thousands and millions of years, some of those paths lead inward. The inner solar system might see a modest increase in long-period comet activity starting a few million years from now, a delayed consequence of 10 seconds that nobody alive today would ever witness. Now the sun is back. Permanently, as far as anyone can tell. The fusion reactions resume, or continue, or never stopped, depending on what vanishing actually meant. Earth's orbit is shifted by a distance your eyes can't resolve. The other planets are similarly nudged. The solar system functions. Seasons continue. Crops grow. Rain falls. From a physical standpoint, almost nothing is different. But everything is different. Because before this happened, the sun was a constant. Not just in the sense of being reliable, but in the deeper sense of being a given. It was the one thing nobody had to worry about. The ground might shake. The weather might destroy cities. Volcanoes might erupt and pandemics might spread. But the sun would rise. Every model of the future, from climate projections to space colonization timelines to the projected lifespan of human civilization, assumed solar continuity as a foundation. A background constant that required no monitoring, no contingency plan, no backup system. 10 seconds destroyed that assumption permanently, not because of what those 10 seconds did, which was almost nothing in physical terms, but because of what they proved was possible. They proved that the most fundamental constant in human existence is not actually constant. And once you know something can break, you never stop watching it. Every sunrise after this event carries a question that never existed before. Is it going to stay? Solar monitoring becomes the most funded scientific program on Earth. Telescopes that used to scan distant galaxies are redirected to stare at the sun continuously. Governments build early warning systems for an event they cannot predict, cannot prevent, and cannot explain. New philosophical and religious movements form around solar anxiety. Children grow up with a fear that no previous generation has ever had. The fear that the light might go out again, maybe next time for longer than 10 seconds. Earth's orbit will wobble for millennia. The solar system's architecture will slowly drift from its pre-event configuration over millions of years. A scattering of comets in the deep outer solar system will begin lazy spirals inward on timescales longer than human civilization has existed. None of these physical changes will be perceptible in a human lifetime. They are abstract, mathematical, theoretical concerns for future species on a future Earth. But the psychological wound never heals. Because humans don't process risk with math, they process it with memory. And now humanity has a memory that cannot be unlearned. The sun went out, it came back. Nobody knows why. Nobody can promise it won't happen again. And every time a cloud passes overhead and the room goes dim for half a second, 8 billion nervous systems fire a signal that didn't exist before this day. A tiny, involuntary flinch. A microsecond of, is it happening again? The sun didn't break anything in 10 seconds. It broke trust. And trust in a thing you cannot control is the most fragile structure humans have ever built. A millimeter of orbital drift will take 1,000 years to matter. The dread took 10 seconds.